Okay, so let's see, we are here. And by the way, you can see now we're halfway through the course because after today, I'm going to be on this side of the paper, right? So that tells you we're getting past the halfway point. Okay, so 9-6, next time 9-7, 9-9. So our next exam is Tuesday, the 27th. Okay. And you've already had a couple of tests, so you know what it's all about. So what are you responsible for? You're responsible for all of this. And you turn in all the homework on that date also. By the way, I'm changing the assignment a little bit from 9.6. It was originally 1 to 30. I'm going to make it 5 to 30. What's unfortunate is I'm not even sure if my problems match your problems, so if I have the right questions. But for now, let's make it 5 to 30 and 37 and 39. Now, when I do the even problems, I notice that my evens, for the most part, don't match yours, but they're off by 1 maybe. So maybe my 14 is your 16 or vice versa, or something like that. Okay, so I noticed that a lot of problems that I'm going to show you, the numbering is a little bit off, but it may be the same. I don't know. We'll see. Okay, so again, let's make it 5 through 30, 37, 39. And with that being said, I think I'm going to end starting with problem number 4. Okay. All right, so I'll lecture a while and then save you some time at the end for the quiz. As usual, the quiz isn't due until next Tuesday. So as usual, you have plenty of time, but many of you like to get it over with. And I often say, I find for not just my class here, but all my classes, when I do something like this, there's a lot of students who turn it in right away. So like our class ends at 7. I get a lot from 7 to 8. And then a lot of people turn it in right at the last minute. So just the last half hour before class. And then during the weekend, it's kind of a smattering here and there. Okay, but again, if you submit your quiz early enough, I try to respond within 24 hours. And then if something isn't quite right, I can say, oh, try this and try that. And you have a chance to fix it. But again, if you submit the quiz like 5 minutes just before class on Tuesday, I'll let you do that, but I won't have a chance to give you, second opportunity in case something isn't right. Okay. All right, so that's what's happening again. So we're doing 1 section a day. More derivative roots, 9-6. Next time 9-7, 9-9. I don't, but yeah, let's say I'm not going to give you a quiz next Thursday because that wouldn't be fair for me to give you a quiz and then you have to test on Tuesday, right? So no quiz the following Thursday. I would just make you worry about the test. All right. So here we go. Whoops. Okay, so 9.6, it's something called the chain rule now. It's page 590 in my book. Again, that doesn't match your book necessarily. Chain rule and the power rule. Okay, and let me show you how it works. Now, the symbols that I have actually are correct. Where am I? Page 591. So you might have a hard time understanding what it's talking about. But here you have a function inside a function. You're going to have a function inside a function. You have y equals f of u and u equals g of x. Okay. So that u is another function. We're going to take f prime of u, which is f prime of g of x, and multiply it by g prime of x. Okay. Now that might be a little bit hard to explain. I'm going to write it in another fashion, which I think the book should have done, but I don't think our author does that. Let me double check. No, the author doesn't do it. But I'll give you my version, which is not really my version. A lot of other books do this also. Okay. I'm going to write it like this. See where it says f of u? But u is g of x. So pretend you erase that u, make it g of x. It looks like this. Okay, so then f prime of u would be f prime of g of x, and then multiplied by g prime of x. Okay, this is usually the version of the chain rule that you see in most books. And yes, I realize right now you're probably saying, huh? I have no idea what you're talking about. Okay, so hopefully you'll get the hang of it once we do some problems. Okay, there's going to be an outside function and there's an inside function. Okay, so in particular for these problems, it's not just taking the derivative of x cubed. It might be, whoops, almost dropped my book here. It's going to be something more complicated, cubed. Okay, so we take the derivative of the outside function with respect to the inside, as we say, and then it's times the derivative of the inside. Okay, and the best way for me to show this is to start doing some homework problems with it, and hopefully you get the hang of it. Okay, but there are more than one function involved. Okay, it's not just one function, so it's not just x cubed. It's going to be blah 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 cubed. So how do I differentiate blah 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 cubed, so to speak? Okay, so here we go. Okay, and again, my problems might match, it might not match, but it's okay. We're still learning from it. Okay, so 9.6, page 594. Okay, so I'm not sure if these problems match. I notice it might be off by 2 or so in my book, but again, nevertheless, you're learning how to do it. That's the main thing. Okay, so this is called the chain rule. Now, chain rule. Okay, let's start off with this one. Number 4, g of x is 3 minus 2x raised to the 10th power. Okay, so whether this matches yours or not, it doesn't matter. You're learning how to do it. If it matches, great. If it doesn't match, you're learning how to do it. Okay, now, it's not just x to the 10th. We know how to take the derivative of x to the 10th, 10x to the 9th. But it's not just x to the 10th. It's something more complicated to the 10th power. Okay, so here's the way the chain rule works. Okay, so 10 comes down. You should be familiar with that. 3 minus 2x to the 9th power. You should be comfortable with that. Okay, so 10 comes down. 3 minus 2x to the 9th power. Now the new thing, negative 2. Where is this negative 2? That's the derivative of the inside function. So you have to multiply by the derivative of the inside. So that's what this is talking about now. Okay, you take the derivative of the outside function. Okay, so 10, 3 minus 2x to the 9th power. Okay, and then you multiply by the derivative of the inside function. Inside is that g of x. So the 3 minus 2x, that's like g of x. So multiply by negative 2. And then the last thing is just do something like 10 times negative 2. So final answer, negative 20, 3 minus 2x to the 9th power. So what do I simplify? Only easy things, like 10 times negative 2. Certainly, we're not going to multiply that out. Forget that. So we're not going to do that, of course. So this is called the chain rule. Right, so I'll do a bunch of problems involving that. Okay, number 6. K of x is 5/7 2x cubed minus x plus 6 raised to the 14th power. Okay, so it's not just x to the 14th, it's blah, blah, blah to the 14th. Okay, so it starts off the same. I'm going to go 14 times that, blah, blah, blah to the 13th power. But then the new thing is I have to then multiply by the derivative of the inside. Okay, so what's 14 times 5 over 7? You can try it out. It comes out to be 10. 14 divided by 7 is 2, right? And then 2 times 5 is 10. Okay. Then 2x cubed minus x plus 6 now gets raised to the 13th power. Okay, so everything up to here you should be okay with from last time, right? 14 times that comes out to be 10. Blah, blah, blah to the 13th power. Now the new part, the chain rule says it's times the derivative of the inside function. So the derivative of the inside is 6x squared minus 1. And yeah, in this particular case, I'm just going to leave it. I suppose you can multiply 10 times that. I would not object to your doing that. You don't have to do that, but certainly don't raise that to the 13th power. Okay, you don't want to do that. Okay, so this is called the chain rule, where it's not just x to a power, it's something more complicated to a power. Okay, here's number 8, or my number 8. P of q equals 4 times 3q squared minus 1 to the 4th power minus 13q. Okay, well, this derivative is easy, right? The derivative of negative 13q is just negative 13. right? So get that out of the way. Okay, so I just have to worry about this thing. I'll cover this part up first. Whoops, cover that up. All right, so to differentiate this, 4 times 4, 16. 3q squared minus 1 raised to the third power. And now the new stuff, times the derivative of the inside function. So what is the derivative of 3q squared minus 1? 6q. And yeah, there's that minus 13, which is the derivative of negative 13q. And yeah, what's easy to do? Multiply 16 times 6 is 96. And normally you put the q in front. So best final answer, 96q times 3q squared minus 1 cubed minus 13. And there we go. Okay. All right. All right, number 10, or again, my number 10. P equals q cubed plus 1 to the negative 5 power. And let's see. Yeah, I see that here. Now, this time the problem already starts with a negative exponent. So that means I'm allowed to leave my answer with a negative exponent. So I don't have to put it in the denominator and stuff like that. Okay? So once I get my answer with a negative exponent, I'm allowed to just stop. All right, so negative 5 comes down. Q cubed plus 1 raised to the negative 6 times 3q squared. You say, where's that 3q squared coming from? It's the derivative of this inside function. Okay, the derivative of q cubed plus 1 is 3q squared. And yeah, then just multiply negative 5 times 3. So negative 15q squared times q cubed plus 1 raised to the negative 6 power. All right? All right, now, because I have this new chain rule now, I can avoid doing the quotient rule quite a bit. Okay, so here's my number 12. G of t equals 1 over 4t cubed plus 1. Okay, now, if I have a constant on top, I normally would prefer to do this. Okay, let me just say right here, I could do the quotient rule. In fact, I'm going to show it to you with the quotient rule in a second. But the quotient rule is probably one of our least favorite. There's the most amount of stuff to do in the quotient rule, right? You got to do what? Bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the square of the bottom. Okay? But if I change it to a chain rule, make it look like this, right? If I bring this upstairs as 4t cubed plus 1 raised to the negative 1 power, this is going to be a lot easier to differentiate. Okay? And I say differentiate. What's differentiate? Take a derivative. Okay, so here we go. G prime of t. Negative 1 comes down. So if a negative 1 comes down, I only have to write the negative, right? I don't have to write the 1. 4t cubed plus 1 raised to the negative 1 minus 1 is negative 2. And then by the chain rule, it's times the derivative of the inside, which is 12t squared. And yes, this time, because the problem started with no negative exponents, I shouldn't leave my answer with negative exponents. So we know what that means. Bring this back downstairs. So leave on top the 12t squared. So negative 12t squared over 4t cubed plus 1 squared. So that's the derivative. Now, the problem's actually finished, but I'll show you what happens if you did the quotient rule. So quotient rule. Bottom times the derivative of the top. What's the derivative of 1? 0. So this is all gone. I like that. Minus the top, minus 1, times the derivative of the denominator, 12t squared. All over the square of the denominator, so 4t cubed plus 1 squared. Clean it up, negative 12t squared over 4t cubed plus 1 squared. And notice you do get the same answer. So either way, you get the same answer. Okay? But normally, if you have a constant in the numerator like this, it's easier to do the chain rule than the quotient rule. And I'll demonstrate that for the next several problems. Okay. Okay, 14 is like that. We just have a harder exponent, 3 halves. So y equals 1 over 3x cubed plus 4x plus 1 raised to the 3 halves power. Again, I will write it as 3x cubed plus 4x plus 1 raised to the negative 3 halves power. That's a negative 3 halves there. And then do the chain rule. Okay, so here we go. Y prime, negative 3 halves, 3x cubed plus 4x plus 1 raised to the negative 5 halves. Oh, I know what I was saying here. This is negative 3 halves minus 1. That's negative 3 halves minus 2 halves. Couldn't read my own writing there. So negative 3 halves minus 1 minus 2 halves is negative 5 halves. Okay. And then by the chain rule times the derivative of the inside. So what is the derivative of the inside? 9x squared plus 4. Okay, then I just clean it up. Negative, let's see, 3 is on top, that's on top, 2 is on the bottom, that comes downstairs because of the negative exponent. So my final answer is negative 3, 9x squared plus 4 divided by 2. That 2 is the same as that 2. And then this 3x cubed plus 4x plus 1 stuff to the 5 halves in the denominator because I have a negative exponent there. Okay. Right, 16. Y equals the square root of x squared plus 3x. Find the derivative. So square root means raise something to the 1/2 power, right? Okay, so it's not as easy as just x to the half. It's something more complicated to the 1/2. So I have to do the chain rule. Right, so dy dx, which also means derivative. So I'm going to use all the symbols. Y prime, k prime, dy dx, still means derivative. Okay, 1/2 comes down. X squared plus 3x raised to the 1/2 minus 1. 1/2 minus 1 is negative 1/2. And then by the chain rule times the derivative of the inside, 2x plus 3. And now I just clean it up. So that's on the bottom. The negative 1/2 means put it downstairs with a square root, and that's the only thing on top. So 2x plus 3 is on top. On the bottom is 2 radical x squared plus 3x. Okay. All right, my 18. 5 radical 1 minus x cubed over 6. Okay. Treat this as a coefficient of 5, 6. I don't want to do the quotient rule if I don't have to. Okay, so it's much easier to think of this as 5, 6 as a coefficient. Then I don't have to do the quotient rule. And we know that square root means raise it to the 1/2 power. So 5, 6, 1 minus x cubed raised to the 1/2 power. That makes it much, much better. Okay. All right, so y prime, multiply these two. 5 over 6 times 1 over 2 is 5/12. 1 minus x cubed raised to the negative 1/2. Same game as over here, completely identical. Times the derivative of the inside, that looks like negative 3x squared. Okay, let's see. There's a negative. 3 cancels with a 12, leaving me with a 5 over 4. X squared's on top. Square root goes on the bottom because there's a negative. So negative 5x squared over 4 radical 1 minus x cubed, and just stop there. Okay, 3 cancels to 12, that's a 4. X squared's on top, yeah. So there we go. All right, then it's starting to get a little bit more complicated with number 20. So y equals 1/2 parentheses, square root of 2x minus 1 minus square root of x. So the author seems to like a lot of these square roots. But we know whenever we have a square root, that means raise it to the 1/2 power. So 1/2 2x minus 1 to the 1/2 minus x to the 1/2. Okay, this one doesn't involve a chain root. That's just as easy as last time. It's just x to a power, so that's a power root. This one's still going to be chain root. Okay, what do I do with this 1/2? Just leave it. This is 1/2 times a function. So by the constant multiplier root, the derivative is 1/2 times the derivative of the function. Okay, so there's the 1/2. I'm done with it. Forget about it. And now I'll differentiate this. Okay, so never mind about that 1/2. This is going to give me another 1/2. So 1/2 comes down. 2x minus 1 raised to the negative 1/2. Then by the chain root times the derivative of the inside, which is just 2. And very conveniently, these cancel out, the 1/2 and the 2.
Professor,
Yes.
why do we keep the 1/2?
Yeah, this 1/2 is a constant multiplier. It's 1/2 times this function. The derivative is 1/2 times the derivative of the function. Right? It's a more complicated function. Suppose it's at 1/2 x squared. What would I do? 1/2 times the derivative of x squared. So whatever is behind my ruler, the derivative is 1/2 times that. So I leave the 1/2 alone. There it is. I'm finished with it. And now I'm going to differentiate that stuff. Okay, so 1/2, 2x minus 1 to the negative 1/2 times 2. So these cancel out. And the derivative of this is minus 1/2 x to the negative 1/2. Okay, so this 1/2 stays there. I guess you could put it in, but you don't really have to. Okay, these cancel out, so I have 1 over square root of 2x minus 1. Again, the negative 1/2 means drop it into the denominator. Same thing here, negative 1 over 2 radical x. Okay. All right, now let's see. My problem number 24. This time they want the, well, it may not be the same in my book as your book, but the language is slope of the tangent line, instantaneous rate of change of the function, same thing. So again, same answer for A and B. Take the derivative, plug in whatever they're going to tell you, and go from there. Okay. So y equals blah, blah, blah at 1, 0. By the way, they didn't have to tell you the 0. In fact, I think some of the problems, it just says x equals whatever. So if it just says x equals 1, you plug in to find 0, right? So like for this one, suppose they only said x equals 1, right? Plug in 1, 4 minus 5 plus 1 is 0, and 0 cubed is 0. So that's how you'd find that out. Okay, so I find the derivative, and then I plug in 1. So how do you differentiate blah, blah, blah cubed, right? So 3, blah, blah, blah squared. And then by the chain root times the derivative of the inside. So the derivative of the inside is 12x squared minus 5. Okay. Now I plug in 1. You say, what about the 0? Well, 0 is for y. But my expression doesn't have any y to plug in, so I only plug in 1. So y prime of 1, put a 1 there, and there, and there. Okay. But you may notice 1 cubed is 1. Minus 5 times 1 is minus 5. So it's 4 minus 5 plus 1, which is 0. So if this is 0, 3 times it is 0. Whatever that is, times that is 0. So the answer is 0. So the slope of the tangent line is 0. The answer to A is 0. The answer to B is 0. It said what? Slope of the tangent line, instantaneous rate of change. It all means the same thing. Okay. Then my 28, write the equation of the tangent line to the graph of each function. Okay, so we know what that's about. You got a point and a slope. Plug it into y minus y1 equals m times x minus x1. And never mind about anything after that. It says as a check graph, but so we're not going to graph it. You're not required to have a graphing calculator, so just go with it.
Professor, this is 9.6.
I'm doing 9.6, yes.
Those questions were like completely different than mine. Mine had
Yes, I
25.
realize.
Okay, all right.
Well, they're not, I don't think they're completely different. They're off by maybe 2 or something like that, maybe. But again, that's what I mentioned at the beginning. The main thing is you're learning how to do this stuff. Right?
Yeah, okay.
Okay. Like actually, this 28 happens to be 30 in my book or something like that. But anyway, whatever. Okay, so y equals this function at x equals 2. So first thing I'm going to do is plug in 2 to find the y coordinate. So it's not the same as this one where they gave me the y coordinate. I have to plug in and find the y coordinate. So I plug in 2 cubed minus 2. Okay, that's 8 minus 2, which is 6. So 1 over 6 cubed, 6 times 6 times 6 is 216. So the y coordinate is 1 over 216. So 2 comma 1 over 216. All right, so that's my point. Now I have to find the slope. Slope means derivative. All right, so again, to differentiate this, I'm going to bring this upstairs and make it to the negative third. So x cubed minus x raised to the negative third power. Okay, because I don't want to do the quotient root. Right, so y prime, negative 3, x cubed minus x raised to the negative 3 minus 1 is negative 4, times the derivative of the inside, which is 3x squared minus 1. Okay.
Professor,
Yes.
why is it x cubed minus x to the negative 4 and not negative square?
Okay, so I have to subtract 1. Remember, negative 3 minus 1 is not negative 2 because they're both negative. Negative 3 take away 1 is negative 4. Okay. Right? Negative 3 minus 1 is negative 4.
That's right.
Right?
Thanks.
It's easy to forget that when you have, but if you think of the number line, negative 3 is here, negative 4 is that way. Okay, so clean it up. That goes back downstairs, and I have this. So this is the expression for the derivative. Now I plug in 2. So 2 goes there, there, and there. So here we go. Negative 3 times 3 times 2 squared minus 1 over 2 cubed minus 2 raised to the 4th power. Okay, so this is going to be kind of bad, actually. Let's see. 3 times, that's a times there. 3 times 4 is 12. 12 minus 1 is 11. So negative 3 times 11. This is 8 minus 2 is 6. So it's 6 to the 4th power. 6 times 6 times 6 times 6. Okay, I can actually cancel the 3 with a 6, give me a 2 on the bottom. So I have negative 11 over 2 times 6 cubed. I already figured that out was 216 way back over here. Anyway, comes out to be a negative 11 over 432. That's my slope. Unfortunately, the author doesn't give us some very nice numbers. But anyway, so slope, point. So x1, y1, m. So here we go. Y minus y1, y minus 1 over 216 equals m times x minus x1, 2. So x minus 2. So that's the equation of the tangent line. Equation, EQ, equation of the tangent line. And just leave it like that. Okay, that's it for that one. And let's see. well. I have my number 30 here, but I'm not quite sure you have the same kind of questions involving it.
It's the same.
Number 30?
Mhm.
You have that? Okay.
Mhm.
All right. So, I skipped B because B was a graphing calculator exercise, I think. Right? So we'll forget about that. And so let me lose the book here. So f of x equals this thing, 10 minus parentheses, x squared minus 2x minus 8 squared. I'm just looking more in my book. Doesn't seem to have that type of question. Oh well, anyway. So find a derivative. The derivative of 10 is 0, so forget about it. Derivative of this is negative 2 x squared minus 2x minus 8 raised to the first power times the derivative of the inside, which is 2x minus 2. All right, now I want to set the derivative equal to 0 for part C. Okay. And yeah, that problem seems to disappear in my book, but does it say something like horizontal tangent or anything on that? Okay. But what would make me do that is you want the slope equal to 0, or it might say horizontal tangent. Okay. Horizontal tangent line means the slope is 0. Okay. So I take the derivative and set it equal to 0.
Professor, sorry, a quick question. Why do we have minus negative 2?
Why do we have negative 2? This 2 comes down and multiplies by negative 1. I'm trying to take the derivative of negative x squared minus 2x minus 8 squared.
And we just lose 10, right?
The derivative of 10 is 0. So I don't have to write it. So yes, it just gets lost. Okay, so I'm here. This factors into x minus 4, x plus 2. So if all of this is going to equal 0, that means either this one is 0, which is impossible, or this one is 0, or this one is 0, or this one is 0. And I just set them all equal to 0. So x minus 4 equals 0, x equals 4. X plus 2 equals 0, x is negative 2. 2x minus 2 equals 0, a little bit of algebra, x is 1. Okay, then part D, it asks for the y coordinates, I believe. So that means I plug in 4, negative 2, and 1 back in the original. That's all. Okay, so I plug in 4 there and there. So 10 minus 4 squared minus 2 times 4 minus 8 squared. 10 minus, okay, this is 16 minus 8 minus 8. That's 0. And 0 squared is 0, so that's 10. So the ordered pair of the point is 4 comma 10. And do the same thing for negative 2. So plug in negative 2 right there and right there. So it's 10 minus bracket negative 2 squared minus 2 times negative 2 minus 8. Okay, so that's 4 plus 4 minus 8. That's also 0. That's nice. So negative 2 comma 10. But when I plug in 1, I don't get 10. Plug in 1 here and here. So 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8 is negative 9. So that's negative 9 squared is 81. 10 minus 81 is a negative 71. So I have the point 1 comma negative 71. Okay. All right, now, I'm almost done. The only thing I had left were some word problems. Unfortunately, I'm not sure if it matches because it doesn't seem to match mine. So this was my 37. And can you tell me if you see anything like that for 39? A revenue function?
The same, Professor.
It is the same? Okay, good. All right, so I'll do 37, let you do 39 your own, and then I'm done. And then I can give you the quiz, and then we're done for the day. Because we don't want to go too much longer because it's so hot, right? Burning up here, right? Okay, so R for revenue is 1500x plus 3000, 2x plus 3 to negative 1 minus 1000. Okay, so I believe the language says the marginal, right? And again, I can't seem to find that problem here. Oh, I see, it's actually my 39. Well, okay, so find the marginal revenue, means derivative, when 100 units were sold. So that means I'll plug in 100 and interpret the result. Okay. So find the derivative. Derivative of this is easy, 1500. Derivative of this, oh, the derivative of negative 1000 is 0, right? So forget about that. So plug in negative 1. Negative 1 times 3000 is negative 3000. 2x plus 3 to the negative second power. Negative 1 minus 1 is negative 2, times the derivative of the inside, which is 2. Okay, so clean it up. 1500 minus, let's see, 3000 times 2 is 6000, right? 6000 over 2x plus 3 squared. Okay, so that's the marginal. So again, marginal means derivative. Velocity means derivative. Slope of the tangent line means derivative. Instantaneous rate of change means derivative. Okay, there was that page that had all that. You don't really have to memorize it. It's this whole chapter is about derivatives, so you know it's not going to be anything else. Okay, so I plug in 100, r prime of 100. So put 100 right here. 2 times 100 plus 3 is 203. So I got 1500 minus 6000 over 203 squared. Punch it in the machine, 1499.85. It's the marginal revenue when I've sold 100 items. So what does it mean if we sell the next item, the 101st item, we will make approximately $1,499.85, or you can round it off to $1,500. Okay, so in economics, the marginal revenue is the amount of revenue for making the next item, not the grand total, not the grand total out of everything, but just the next item. Or you can say in this case, the 101st item. Okay. All right, so I'm done, folks. Let me check the chat and see if you have any questions. Okay, so let's see. Okay, thank you for, all right. Okay, so does anybody want to ask me questions about today's lecture? You can either unmute yourselves or put it in the chat. If not, we'll go to the quiz and we're done. Okay, so anybody have a question, please?
Could you do number 18 again or explain it again?
18, okay.
I didn't understand where the half, the 1/2 came from when you started.
Okay, this one over here?
Yes.
Okay, so 5/6, I write it as a coefficient. Okay, so that's 5 and that 6 is the same as that 5/6. Okay, that way I don't have to do the quotient rule because I don't want to do the quotient rule. And square root always means raise something to the 1/2 power. Is that what you mean?
Yeah.
Uh-huh. So square root always means to the 1/2 power. The number on top is the power. The number on the bottom is the root. So when you have a square root and you don't see anything else there, the understanding is that the exponent is a 1 and you pretend there's a 2 there. Okay. Otherwise, you would have to put the 3 if it's cube root, a 4 if it's a 4th root, and so on. Okay. So if I can put a little parentheses here, x to the 1/2 always means square root of x. Okay. So square root of 1 minus x cubed means that. Okay.
Thank you.
You're welcome. and let's see. Number 20. How do you bring down the half in front of the problem? Okay, so this is the way that problem started off with. Okay, so it's 1/2 times a function. So that half just carries all the way through. This half is the same as this half, the same as this half, same as this half.
Professor,
If
the half
1/2
was in-
times a function, leave that half alone. Now I'm just going to totally ignore it. Completely ignore it and work on taking the derivative of this. Right, so now it's 2x minus 1 to the half minus x to the half. Okay, so again, I'm finished with this 1/2. Okay, maybe there's too many 1/2s in the way, but that 1/2 in front, I'm already done with it. So now I'm trying to differentiate this. So that's 1/2, 2x minus 1 to the negative half times 2. Maybe the confusion is there's another half here and a half here. Okay, but suppose in front here was a 7. That would be a 7, that would be a 7, that would be a 7. Maybe the confusion is that this happens to be another half, but that's just coincidental. Okay, so by the process of taking a derivative, that 1/2 comes down in front like that. 2x minus 1 to the negative half times 2. Okay.
Professor, that is not my question. The original question, the half is inside the square root.
The half is inside the square root. Okay, then maybe I don't have the same thing as you. Does the problem look exactly like this or no?
No,
Oh, okay. Well, we're talking apples and oranges anyway, so. I don't think I can address that issue because I may not have that question anyway, so. Yeah. So we're talking about a different question ultimately. Okay. Right, anybody else, please?
no, in the textbook, in the exercise, the half is inside the square root, Professor.
The half is inside the square root. Well, yeah, again, we don't have the same book, so we're not talking about the same thing. Unless, well, I'll show you exactly what I have. All right, there's no way to do this fast. Does it look like that?
Yes, that's 22. Yeah, the half is inside, right?
Okay, so is your question about this problem?
Right.
Yes, it's much easier to write it as a half. So I changed it to this. Can't find it anymore now. But what I have is equivalent and much easier than this. That's what I'm saying. Think of it as 1/2 times all of that. It's equivalent. That way I can avoid the quotient rule.
Okay.
Okay. And
Thank
right
you.
now I can't seem to find it, but it was there and it's on the recording. So this is equivalent to what I had. That's what I'm trying to say. Okay. Okay. All right. Anybody else, please? All right. It's time for the quiz. All right. So get your cameras out. I'll set you up in your breakout rooms and you'll get in your group. And as usual, do next class meeting and then have a good weekend. I hope this one's not that hard. Okay, so... All right, here we go. 3 questions. Find the derivative. I will read it to make sure we got it, but if you already got it, you can just start. Number 1 is f of x equals 5x squared plus 3x plus 1 times 4x minus 6. looks like a product rule. Second one, y equals x minus 1 over x plus 1, looks like a quotient rule. Number 3, f of x equals 3x minus 10 to the 4th power, looks like a chain rule. Okay, and in each case, I do want you to simplify the algebra after you're done. It should not be that bad. So after you finish the product rule, quotient rule, or chain rule, go ahead and simplify the expression. It should not be that bad in this instance. Okay. I will assume everybody has it by now, so I'll stop the share and get your breakout rooms going. All right, so get started with it. I'll blab a little longer while I set up your breakout rooms as usual. Once you're in your breakout rooms, and you can talk about it, but you can leave anytime between now and 6:55 and submit the quiz before the next class meeting, okay? So here we go. Okay, so you have an invitation to join your breakout room. So if you could do that, please.